We're going to go ahead and get started with our presentation. I know that there's still a few folks that need to get food. Feel free to get up and move about as you need to. Now I'm going to introduce our speaker. And please be thinking of some discussion questions. I know Dr. Byfield is willing to answer questions along the way. We will have plenty of time for discussion after his presentation. So today's meeting will feature a presentation and discussion on AI in manufacturing led by Dr. Richard Byfield. He earned his undergraduate degrees in mathematics and physics from Central Methodist University and went on to complete both a master's in statistics with a focus on data analysis and a PhD in mechanical and aerospace engineering at University of Missouri. His doctoral work includes extensive research in AI models for intelligent systems control. In addition to his academic background, Dr. Byfield brings 6 years of hands-on manufacturing experience and currently serves as Director of Mechatronics at Moberly Area Community College. His presentation will explore how AI technologies such as robotics, machine vision, and predictive maintenance are shaping the future of manufacturing, along with key opportunities and challenges for industry. Please help me in welcoming Dr. Byfield.
Okay, does anybody in here do marketing? No, maybe? Okay, well then ignore this picture because I know marketing departments hate AI generated slop, but it's okay. Okay. So like Amy said, my name is Richard Byfield. I currently serve as the Director of Mechatronics at MACC. I'm also an adjunct instructor at the University of Missouri for their new engineering technologies program, which is just the 4-year equivalent to the 2-year mechatronics or industrial maintenance program. So today I'm going to kind of cover how AI is being used today in manufacturing specifically, because that's more of my focus. So to start, who in here is a student? Perfect. There's going to be a quiz at the end, so make sure everyone's paying attention, right? No, I'm just kidding. Okay, so just a quick outline. We're going to do a short introduction. We're going to cover some background key terms in AI, kind of surface level. We're not going to get very specific. It's good just to understand what you're working with. We're then going to talk about AI models and tools being used today, the AI applications in manufacturing, challenges and barrier, future outlook, and then just a short little conclusion. Perfect. All right. I always like to build context when I talk about AI because there seems to be a great divide happening around AI. People are either completely pro AI or people are completely anti-AI, and there seems to not be much of a middle ground. So why should we talk about AI for the context of Missouri? Well, Missouri does a lot of manufacturing. So currently right now, there's almost about 300,000 manufacturing jobs in Missouri that is continuing to grow over time, with the average pay being right under about $80,000 a year. So it's a very good career to choose. I know if you think about manufacturing back in the day, it was horrible, poor conditions. Well, that's changing. In Missouri, we want to focus on advanced manufacturing. We're not making T-shirts, we're not pushing buttons. We're building the next generation of technologies here in Missouri. Missouri also exports a lot of manufactured material, not just throughout America, but also globally. So believe it or not, the number one thing we manufacture is transportation equipment, and that accounts for about almost $5 billion a year in revenue. Now, we also manufacture chemicals, machinery, food and kitchen products, minerals, computer and electronic products, yada, yada, yada. So we make a lot of things in Missouri. So manufacturing is a core sector of the American workforce. And it's growing, as I said. In my program in Columbia, we have a large manufacturing base, and about every month I get emails from at least 5 to 10 manufacturers saying, hey, we have 4 openings. Do you have students? And I always tell them, yeah, I will in May. Please don't scout my students now because they like to take them before they finish. So if you guys are young and you're looking for a solid career moving forward, manufacturing will be the way to go. Now, the number that we export annually is about $20 billion. Now, I know on the federal level, that's pocket change, but for the state of Missouri, that's a lot of money, right? $20 billion for any of us would be life-changing for generations to come, right? Okay, and again, our exports are rising steadily. So you see here, we had a slight dip in our exports in 2020. We all know that was COVID. It kind of hurt the entire world. But since then, we are continuing to grow. Okay, now if you're interested in where we export a lot of our products, our number one exporting partner is Canada, followed by Mexico, and then places like Japan, Germany, China, India, and so on. So this is where I like to explain why AI is needed. Foreign countries, especially those in Asia that have much less worker rights, they are steamrolling AI. And if we do not compete or if we do not stay up to date with our AI manufacturing, they're going to eat our lunch for the next 20 years and we're going to become a very poor country. I mean, if you look at China and Japan, they have been automating for the last 20 years. China makes, I think, a majority of products for the entire globe. And if they fully industrialize through AI, that number will continue to grow. So we need to stay competitive. The only way to stay competitive and still have high wages is if we deploy AI to become more effective, more optimal. Okay. Now I kind of alluded to this, but why do we care about AI? Well, AI is beginning to be used more and more. So this is kind of an old study. I think it's a questionnaire from Missouri Business reporting AI use during the last 2 weeks. So this is all from September of 23 up to July of 25. So in September of 23, right around ChatGPT began getting very popular, only about 3% of respondents were using ChatGPT. Well, since then, that has increased to 10. That is almost a 300%, or it's an over a 300% increase. So more and more of your competitors are starting to use AI. So we have to be globally competitive, but we also need to be competitive in Missouri with our other competitors, right? Not trying to build divisions, but we all went to Excel. Now, they also did another study where they asked, has the use of generative AI tools at work improved your productivity? Now, a vast majority said it significantly improved. Another vast majority said that it somewhat improved. This no change in productivity would be the anti-AI people. And then the super anti-AI people right here said it decreased their productivity, which it absolutely does not. But again, I talk with a lot of older faculty at MACC and Mizzou, and there's just, people don't like change. And that's totally understandable. When I was in graduate school, I started before AI was easily available to everyone. When I started in grad school, I had to build my own AI models. Well, then ChatGPT came out, and at first I was totally against it because that just took away one of my expertise. Until I started using it and I realized, wow, this is way faster than me building my own models. So I'm going to take full advantage of this. Any of you guys that are students right now, you are at a pivotal point in history where you will become the leaders of the future using AI if you pick it up now. When you're young, it's very easy to learn new technologies. As you grow older, it becomes harder and harder. I like to think of my dad. He's a business owner. When he was in school, there were not computers. Now it hurts me to watch him type on a computer because he does the 2-finger thing, you know. Anyone that grew up with computers can type, you know, all 5 or all 10 fingers. Great example of why you should learn AI now. Okay. Now, the information I just showed was more for generative AI. Now, this is going to be why should we talk about AI in manufacturing specifically? Well, there was a study done across the entire U.S., I think it was the end of last year or the beginning of this year, where they found that 40% of manufacturers are using AI tools such as chatbots and in manufacturing operation. And more than 80% of manufacturers said they plan to use AI in the next 2 years. AI is kind of like Pandora's box, if you know anything about mythology. Once the box is open, you cannot be closed, right? Even if we close it across America, it's not going to be closed globally, which would be a horrible decision for us as a nation. Now, why are manufacturers investing in AI? Well, 72% of respondents said it reduced costs and improved operation efficiency. As products cost less to manufacture, they become cheaper for consumers, and they're able to pay employees more. especially as employees become more specialized in what they do, they will become more valued and you'll make more money, right? A good example is if you're like a laborer for the union and you're just carrying bricks all day, you might make, $50,000, $60,000. If you're a control technician at Solventum in Columbia, you make $90,000 to $100,000 a year with a 2-year degree. So it's really important that we learn how to use and adopt this technology. Now, I think the educational people in here will know about this, but 2 months ago, the U.S. Department of Labor released their AI literacy framework. So at the educational level, AI education is no longer optional. It is going to start to be required. So obviously the federal government came up with a 5-step plan on what students or how students should be able to use AI. So they should be able to understand AI principles, explore AI uses, direct AI efficiently, evaluate AI outputs, and use AI responsibly. Now, I'm not going to talk about this too much because today we're going to focus more on manufacturing. But if you're interested, this is available online. You can just Google it. And there's actually a nice paper that goes along with it. This is going to be our goal or our plan as a nation moving forward with AI. And this is just some effective delivery principles. But again, we're not going to spend too much time on this. Okay, now I want to talk about my background for a second. I like to build credibility. I know I'm young, but AI is a new technology. So most of the experts in AI at the graduate level are professors that have been in the field for 40 years that don't know anything about AI, but they have a lot of grad students that do everything for them, right? So that's kind of where AI is at that level. My advisor is an AI expert, and he knows nothing about AI, but I don't know. Grad students are kind of like free labor if you're familiar with that setup. But okay, so some of my projects that I've done with AI, one of my papers I published was exploring how to predict joint angles using an echo state network. So what we did is we attached EMG signals or EMG sensors on the bodies of patients with osteoarthritis. We also recorded their joint angles and we had them step off a box to record that information. The goal is moving forward, you don't need to know the joint angles, just use EMG sensors to predict those joint angles. You can build an exoskeleton to help with rehabilitation. Now, the exoskeleton or the echo state network is a form of a deep learning network. Without going into too much details, basically imagine you have all your data, throw it in a reservoir, you shake it around, and then what comes out is your prediction. That's the easiest way to explain it. That's actually a problem with AI. There's something called the black box problem, where we actually don't know how AI learns. We know that it's right. And there's research trying to explore how to solve that problem. Okay, my first and arguably worst publication, I used EMG again to control a robotic arm. So using EMG sensors attached to the forearms and using hand motions, we were able to control an industrial robot to do different applications. That's more the human-robot interaction. The idea is, this technology is still pretty far out, but the idea is in the future, you can have individuals in manufacturing warehouses controlling the robots with their own body. It can make the manufacturing process a lot smoother. If you have customized manufacturing, obviously industrial robots that do the same thing all day, every day will always be faster than people, but it's a look towards that direction. Okay, a paper that I was a co-author on, we built an AI model to predict or to optimize flash graphene synthesis. So my advisor was the first person in the world. His name's Jin Lin. He's the first person in the world at Rice University to develop flash graphene synthesis. What that is a technique using lasers to induce graphene on a surface. Graphene is a very conductive material. It's a new way to manufacture electronics, okay? We built a model that could do it better and faster than he could as the creator of the process, and he was very proud of that. So this is an example how AI is going to optimize everything that we do. A great example, there was a paper published, I believe by Harvard a few years ago, where they explored human innovation with and without AI. So imagine you have a graph. The y-axis is innovation, the x-axis is exploration. As humans, we are very good at innovating, right? We can try new things. However, we're not good at exploration. Exploration is trying every possible outcome. We are limited in time to explore these different combinations. AI excels at exploration. It can do thousands of iterations, trillions of iterations a second, but AI cannot innovate. So the idea, if we combine AI with our innovation, we can reach new heights in research and throughout society. So that's kind of that was the idea of this paper. Okay, arguably my most known publication, using AI, I developed a new way to estimate blood pressure. So traditionally, when you get your blood pressure recorded, you put a blood pressure cuff on your arm, it inflates, stops your circulation. When the circulation begins to flow, that's your systolic or maximum blood pressure. Once it can no longer hear the flow, that's your diastolic or minimum blood pressure. The problem with that is you can't continuously measure it, and if you do it repeatedly, it actually damages your arteries. So I developed a way to estimate blood pressure from the fingertip using PPG or photomethography sensors. It's the same technology as the pulse ox. Like when you go to the doctor, they put that little clip on your finger. It records typically your temperature, heart rate, respiratory rate, and blood oxygen saturation. Well, if you add a second sensor, you can also include blood pressure. Now, my accuracy was only good if you're young and healthy, because as you begin to age, your PPG wave deforms. But there was actually a company in California that took my research and cited me, tested their model on 76,000 people, and now they have a commercial product that they can sell. So I got a good high five. That's the nature of higher education research. Okay, another paper I published using AI. One of my co-researchers focused his research on horses while my research was on humans, so we were able to work together very well. We had some extra data, so my advisor said, do something with it. Well, I don't know if you know this, but for horses, there's no set point where horses age from young to old. There's a range that ranges between 14 years up to 22 years. Now that matters if you're a veterinarian because there's different things you have to do to horses as they age. I don't know if any of you are familiar with race horses or show horses, but these are like hundreds of thousands of dollar horses that they want to keep very healthy. So what I did using, again, the EchoState network and heart rate data, we were able to quantify when horses age from young to old, and we found it to be about 17 years. And not a very important paper, but had some extra data. We wanted to do something with it. Okay, and then the combination of all my work was in my dissertation, which was titled Automatic Vital Sign Measuring Robot Using Machine Vision and Support Vector Regression. So basically all we did is I used my techniques for estimating blood pressure, I combined it with my techniques of robotic control, and I built an automatic system to record all 5 vital signs without the need of a nurse. The goal here was not to replace nurses, but I don't know if you know this, but nurses are horribly overworked. So our goal was just to reduce their workload. MU Hospital started using these, and then I graduated, and someone else took over the project. So I'm actually not sure where it is right now. But again, we had to use machine vision to identify the target location to record these vital signs. Okay, so all that's to say, I have a pretty good understanding of AI because my option in grad school was to sink or swim, use it or leave, and I chose to learn how to use it. And a lot of you younger guys, you're also going to be at that point, so you need to start learning how to use AI, okay? It's going to keep you marketable moving forward. Okay, so with all that said, I want to quickly cover some background terms for AI, because again, I think most people still think of AI as Terminator, this magical sentient monstrosity that's going to take over the world, right? Well, that's not what AI is. AI is just statistical models predicting what it believes you want the output to be. How good your data is determine how good the output is. That's why I majored in statistics, because I had to build these AI models and I had to have credibility so people believe my models. But okay, just some quick definitions. There's basically 3 areas of AI. There's the big broad term artificial intelligence, followed by machine learning, followed by deep learning. Okay, artificial intelligence are just systems that perform tasks requiring human-like intelligence. We have had AI for such a long time, people don't understand that. You know Netflix, when Netflix recommends a TV show to you or a movie, that is AI. It is mimicking human intelligence. Instead of someone sitting behind a computer looking at your history saying, oh, you might like this movie, AI does that for you. Again, probably the most basic form of AI. Now, machine learning is the back end of artificial intelligence. Machine learning are algorithms that learn from data. Again, everything that uses AI has to have training data to learn the desired output, and then you're able to automate it from then on out. And then lastly, deep learning, which is, I wouldn't say new because all these methods are old if you understand graduate research, but I would say for the average person, the newest approach, which are neural networks with multiple layers that learn complex patterns. So this is how we are trying to recreate the human mind on a computer for intelligent tasks, which has been a nightmare because I don't know if you know this, but we don't understand anything about the brain. The last 20 years on Alzheimer's research was based on a fabricated paper that literally wasted the last 20 years of research. I don't know if you know anything about Alzheimer's, but 20 years ago, a researcher stated that Alzheimer's was due to something to do with the gray matter in the brain. And as that gray matter breaks down, what they found out recently is that researcher took results from 4 different publications, took the results he wanted, and fabricated this research. Just horrible, because again, it wasted the last 20 years of research. So, but okay, all right. Now, there's 2 main types of machine learning, because again, this is the back end, and I promise this is going to be short. I'm not trying to give you guys a stats lecture. But basically, there's 2 ways that machine learning models work. You have classification and regression. So classification will be predicting a class. So if you want to deploy something in your manufacturing line that predicts if a product is good or bad, you know, let's say sort your products by, I don't know, if you're manufacturing different things, you know, classes or any things that aren't numbers. Now classification works on the machine learning side. You basically plop all your data on a 2-dimensional grid, and then you try to fit a line that separates your data. So if your data falls in this line or in this region, it's one prediction, falls in another region, it's a different prediction. Again, really good for pass-fail detection, defect type identification, things like that. Now regression is a little different. Regression tries to predict a physical value, such as how much, how long, how hot. So examples of this would be predictive maintenance, as well as energy consumption forecasting, cycle time estimation, things like that. So instead of trying to separate the data, it just tries to fit a line that best represents your data. So let's say, I don't know, if your value comes out to be 60, you can predict what the other value would be. Okay. All right. Quickly, some common machine learning models. We have curve or line fitting methods, as I shown before, tree-based methods, which are basically trees that partition data down based on parameters. So a good example, if you're trying to predict blood pressure on people, what do you think your first partition should be? Well, probably male and female. Men have higher blood pressures than women typically. So that's the first partition. You partition it down until you get your prediction. And then boosting methods, just take the results from the tree methods, run it back into the model, and reiterate until you get a better result. Okay. All right, and lastly, deep learning architecture. Again, these are neural networks, recurrent neural networks, convolution neural networks, echo state networks, anything that tries to mimic the human mind. So you know our brain, we have interconnected neurons, and when you have a thought, it kind of bounces around and then it comes out your mouth, right? Depending on how smart you are, determines how smart what comes out of your mouth is. Well, that's what we try to mimic here. So we have our inputs, we have our hidden layers, we don't know what happens in here, and then we have the outputs. So people always ask, well, if we don't know what happens in the middle, how do we know if it's accurate? Well, when you train the model, you know the input and you know the outputs. So you optimize these models using mathematical equations until your output matches what you want it to be for your inputs. Then from there, you deploy it without knowing the outputs, and you can further validate it while you use your model. Okay, this one here is called the multi-layer perceptron. But again, this is what most of the models you guys see in everyday life includes these. But imagine there's like 15 of them. Like the AI models that you guys see are a lot more complicated than this. This is just the tools that are being used for the applications. Okay, so that's it for the big level stuff. Now let's actually get in how are AI models being used today? Okay, well, I think the one that everyone here is familiar with is generative and large language models. So generative AI are conversational AI for knowledge work, documentation, support, etc. So easy way to use these would be like email drafting, idea generation, research summarization, etc. So these are your models like ChatGPT, Copilot, Gemini, Claude, and Bard AI. Again, this is what the average person that uses AI will use models like this. And they are very, very useful. As a college professor, I get some not so intelligent emails from my students. Like I had a student the other day email me being like, hey, I'm not going to be in class for 2 weeks because I'm going on vacation. Like, great. I did not tell him what I wanted to say. I typed out my email and I asked ChatGPT to make it sound nicer. So it made a very nice version of what I wanted to tell my students. Okay. Perfect example of how to use AI. Okay. Now getting a little more into the manufacturing side, AI is being used in machine vision systems. So these systems are used for visual inspection, quality control, object detection, things like that. So basically these models allow for real-time defect detection on production lines. Some of these models will be Cognex, Keyence, and even Amazon. Amazon is kind of like the super company that does a little bit of everything. Have you guys seen Amazon fulfillment centers? Seen the inside? They're just robots going all over the place all the time. They use these vision systems so they don't crash into each other. That's one of their approaches. Now, anyone here do manufacturing here for like at the college level? Nope, no manufacturing students. Dang it. Okay. Have you heard of any of these machine systems or vision systems?
I did mostly machining, but yeah, and
Yeah.
that's on a very, very basic level.
Cognex and Keyence are already in the field now. They're basically designing new cameras or updates that can then deploy AI on their vision systems. It'll be very useful moving forward. Okay, now there's industrial manufacturing focused AI. These are AI that they kind of take history or historical data and they combine it with AI for predictive analytics. So they use IoT or Internet of Things platforms with built-in machine learning for equipment optimization. These softwares include Ignition, MindSphere, and PredictX. Ignition is what I use in my facility. I teach my students because Ignition works with Allen Bradley PLCs. Again, basically what these systems do is they record all your information from your manufacturing line for about, I don't know, 30, 60 days. Then from there on, it is able to predict when things are going to fail or when you're going to have problems, or for process optimization. My grandfather is a chemical engineer for Gerber. He's been doing that for like 40 years. And right now at one of their Sweden plants, they're having a problem with their temperature control manufacturing baby food. If the temperature is not right, they have to throw out all of the baby food. So right now, and I kind of helped him a little bit, but we basically designed a model that could record that information and then predict when it's going to go out of whack. Because that baby food's cooked for a good amount of time. And it's not just cooked once. It's cooked in multiple chambers as it goes through the line. If anywhere along that process something goes wrong, you have to throw out the entire production line. Okay. All right, and then robotics and AI. This is the clearest application of AI manufacturing. The primary difference right now is between collaborative robots or cobots and industrial robots. Now, industrial robots are traditional robots. You think of the big robots in cages that are moving very quickly that do the same thing over and over and over. The problem with industrial robots is they do not discriminate, meaning if you get in its way and it grabs you, you become part of the process whether you want to or not. What cobots are doing, they are safer robots that are able to sense their environment and interact with people. We call that human-robot interaction. These robots are typically used when the process is customizable or not the same every time. And if you want a human to be able to interact with the robot for the process. Okay. Now, how the cobots work is typically they have some type of vision system. That vision system allows them to sense their environment, and then they can interact with people. So this is kind of what my first publication focused on. And again, these will be vision-guided robotic systems. Okay. And automated material handling is where you'll see cobots. Now, industry has to balance, though, speed and precision versus safety. I will be honest, cobots are a lot slower than industrial robots. So if you need an application where you don't need people, you keep industrial robots. If you have an application where you need people to be part of the process, you should deploy cobots. Right now, if you're familiar with Spartan Metals, they have a plant in Mexico, Missouri, and Hannibal, Missouri. We've been working with them because they are deploying like 8 cobots on their line because they need to have humans interactive in the process. They can't just have humans completely process. So, okay. We also have predictive maintenance systems. This is going to be the #1 area where AI is going to have a large ROI for manufacturers. So what do these systems do? Well, they are AI models that predict machine failures. So they use real-time time series data. Time series just means data over time. They combine that data with their sensors, and then they're able to, again, predict when these systems fail. These models include Maintenance X, Fix by Rockwell Automation, and Maintenance Connect. Again, this will be the largest area where you see AI in manufacturing. Now I'm going to go over a more in-depth explanation of how it works versus traditional here in a minute. But this is where I get calls all the time by companies asking, how can we do predictive maintenance? Okay. And there's also something called simulation and digital twins. So these are basically virtual models of physical systems. And they use AI to optimize processes and workflow planning. So imagine you're trying to design something, but you want to design it to work under any condition. The old way they used to do this is they would design the system, and they would test it till failure. Well, that takes time and it costs money. If you have this data, you can build a digital twin of your system and do the simulation in seconds rather than over the courses of days and weeks. So it's a faster way to make sure your system is optimal for its given environment. Now, when I was in grad school, my advisor asked me to build a digital twin of the human body. I don't know if you guys know this, but the human body is horribly complicated, and I failed in that project. The best I could do was a digital twin of the circulatory system, specifically related to my blood pressure research. But this is growing more and more. Traditional engineers are using this almost at every level. Caterpillar in, I believe it's South Carolina or Georgia, recently worked with MU to deploy virtual reality systems in order for people to test their equipment. So those equipment had to have virtual twins that react the same way they would react in reality. They're using it for training. Another great way to use a virtual twin or a digital twin. Okay, so that's kind of the models that are being used. And now I want to go into the approaches that they are being used. These two sections kind of blend together a little bit. Okay, so first, AI is going to be used for quality assurance and vision inspection. So I don't know, I mean, maybe you guys are on a smaller level, but I recently formed a company with a co-researcher. We're called Airo, capital AIROW, and we deploy vision systems in manufacturing settings to identify defects. We got a contract to deploy one for Tyson, one of their plants, Tyson Foods, because Tyson experienced like tens of billions of dollars a year in losses due to recalls. The problem with food is if you find metal shavings in an individual package, even if that's the only package that has the metal shavings, you have to recall like the last 3 weeks of anything manufactured on that line. Costs them a lot of money annually. Now, on average, though, recalls can cost companies upwards of hundreds of millions of dollars, okay? Now, this cost also only includes costs associated with retrieval, repair, and notification, not lawsuits. Lawsuits can be another hundreds of millions of dollars. I don't know if you guys are familiar with AT&T. They seem that they get their data breached every other week. I was part of that. My entire social security number was leaked on the dark web, so I have to have all my credit frozen all the time. And AT&T said, sorry, and there was a $74 million class action lawsuit that got settled, and I got like $2,000 out of it. My credit will have to be frozen for the rest of my life, but I get $2,000 as restitution, they call it. So this is where AI can be deployed to stop things like that from happening. So in manufacturing, the number one way this can be used is if you have a vision system on your line, you can identify when products are good, when products are bad, and you can automatically pull them off the line. Okay, basically it reduces the reject rate, and primarily defect detection. I've actually seen some companies use this for sorting. If they manufacture many things in the same line, the AI can automatically sort it. They then have actuators that'll move, grab the parts off, put them in the right setting or the right packaging. Okay. And if you guys have questions at any time, please let me know. You got one? Perfect. What's up?
Is this just visual or is this other sensors as well?
This approach is just visual. Yeah. But there can be other approach. Let's say your objects vary by weight. Well, you can build an AI model to then separate them by weight, by size. Like there's all kinds of things. But right now I'm focusing more on the vision side. Thank you. Okay, process optimization is another large area where AI will be used in manufacturing. I also write PLC or programmable logic code for local manufacturers in the Columbia area. And the number one thing I see is that their PLC code is atrocious. And it's no wonder their employees can't read it because it has like 80% of it's redundant. Like I like to pick on Spartan Metals because I work with them closely, but their code was made about 10 years ago by one of their technicians that had about a 20% understanding of PLCs. So he basically took the code that came with the equipment and then tried to add what he thinks would make the process better. So their process has about 200 subroutines and like 3,000 rungs per subroutine. And they probably only use about 30 or 40% of it. What AI is great for is for optimizing that process. I teach my students to write ladder logic code, and then I teach them to use AI tools to make their code better. because the less redundancy there is in your code, the less computational power you need, the less electricity you use, everything just becomes cheaper. Now, another way that you can do process optimization is by using AI models to optimize throughput and reduce waste. So a good example of this is, let's say you have a manufacturing line. Let's say you have a redundancy or a lag point in your process where it slows the process, I don't know, by 10 seconds every iteration. Well, if you iterate every day, all year, that 10 seconds adds up significantly over time. You remove that 10 seconds, you could see hundreds of thousands of savings throughout the year. Now, this is all theoretical because it would be case by case. But basically, again, how this works is you take your real-time data, you plug it into an AI algorithm, you can optimize your parameters as well as optimize your output. A lot of the large manufacturers are starting to use this. Now, the benefit of this approach is you can do real-time process adjustments. As I was talking about Gerber, in real time, they can determine when something's going wrong in their system. They can send a technician in and fix it. Again, vastly reducing waste and costs. Okay, AI is also being used for supply chain inventory. This is when I love to talk about Taco Bell and Moberly. If you've heard my talk before, you know what I'm about to say. I love Taco Bell, okay? But Taco Bell and Moberly, if you go there on Sunday nights, they will be out of chicken, beef, cheese, tortillas, lettuce, and all they have is like potatoes. But not even the cheese to go on the potatoes, just the potatoes. And it's every single Sunday. If they can deploy AI, they can determine, which they should already know this, but we always have a problem at Moberly Taco Bell on Sunday. Maybe we should give them more product. You know, simple application to make the city a lot happier. I don't even try to go there on Sunday anymore because I know it's going to be a problem. Okay, but here again, the AI can be used for demand forecasting. It can determine, you know, maybe this facility or this restaurant or this plant is going to have a higher demand. We need to make sure they have the products to meet that demand. And then AI is also being used for logistics planning. So again, how this process works is, and everything has to do with data. The only way you can use AI is if you have the data to train your model on. But basically, you gather data, you clean your data, you can optimize your forecasting model, you can refine the forecast, and you can view it. I have a co-researcher. His name is Dowie. When he graduated, he got a job for Facebook. All he does is look at what you view on Facebook. It's all time series data. Based on that, he improves the model to give you the ads that he thinks you want to see. And they pay him like $400,000 a year to do that. That's all forecasting with AI. And I mean, any sales departments, you guys want to do forecasting with AI because it can really help you with your sales. Okay, now the key for the average industry technician is going to be predictive and prescriptive maintenance. So how this works is if you include your sensor data with machine learning, you can have fewer breakdowns. And with fewer breakdowns, you have cost savings and uptime improvement. The number one cost to manufacture, at least in my area, is when a piece of equipment breaks down. Every minute, every hour, every day that that equipment is not running, it is costing the company a lot of money. Now, I like to do a little comparison of traditional predictive maintenance versus AI-driven predictive maintenance. So we can look at the data analysis side, the decision-making, the maintenance planning, and scalability. So the traditional way to do predictive maintenance is it's based on statistical analysis and human experience. What I see in a lot of manufacturers, they typically have one guy that's really good at his job, and they have 10 guys that are okay at their job. And if they ever need help, they ask the one guy. Well, if that one guy's not there, nothing gets done, right? Well, what AI does is it can use complex algorithms to detect subtle patterns and trends. The only reason I was able to develop a new method of blood pressure estimation is because I built an AI model that could determine the small changes that us as humans just can't perceive, right? Only because AI can analyze the data at trillions of iterations a second. Okay. For decision-making, the traditional approach requires human intervention and expertise. Again, your maintenance department is only as good as your maintenance technicians. Now, in my program, I try to train really good maintenance technicians, but some places have some problems, especially if their top guys are out. What AI does is AI can automate decision based on learned patterns. Now, for maintenance planning, typically this is based on manufacturer recommendations and fixed schedules. Okay, what's the problem with these manufacturer recommendations? They assume perfect conditions. They assume low vibration at the right temperature in the right setting, right humidity, right moisture. Well, let's say you have an electric motor. If your shaft is vibrating, those bearings are going to fail sooner than what the manufacturer recommends, because again, everything is based on perfect conditions. Now, what AI can do is it's dynamic and adaptive based on real-time data. That's the key. In real time, it can determine when things need to be fixed or updated. And lastly, the scalability. Again, the traditional approach is limited by human capability, while AI can easily scale up to as many machines that you have as long as you have the computational power. Okay. Now, there's also three main maintenance strategies for maintenance. You have run to failure, which is hardly ever used. You have preventative maintenance, and you have AI-driven predictive maintenance. So for the description, run to failure is where you operate the machine until it breaks. Well, that clearly has very high costs. It's not very efficient, and it's medium scalability because you can run any machine until it fails, right? But again, high cost, low efficiency, industry does not want it. The second approach is the traditional predictive maintenance or preventative maintenance. So this is routine maintenance based on manufacturer guidelines. It has medium cost because sometimes things get missed, has medium efficiency because most of the time your machines do not break, and it has medium scalability because you can only scale it based on how many technicians you need. Now for AI-driven preventative maintenance, it is a proactive maintenance based on AI data analysis. It has very low costs because the machines never break down. It has very high efficiency because your machines never break down, and it has very high scalability. As long as you have the computational power, you can deploy these models across all your manufacturing lines. Okay, what's up?
What kind of power just does it estimate, like hard drive space or server requirements?
Yeah.
Basic
Oh, that's a great question. Well, luckily, there's two approaches to these computational demands. You can do cloud computing or on-site computing. For on-site computing, you would have to build the system that's capable. I couldn't give you an estimate because it depends on your given system. To put it into perspective, I had a very high-power gaming laptop in grad school that some of my models still took like 40 hours to run. But that's an individual device. If you can have much larger computational towers, it can reduce that complexity. But I couldn't give you an exact number.
Learns, does it grow hard drive space?
Yes, and as you increase more, or as you increase the number of lines that are using these AI models. Although luckily, the training takes the most computational power. Once your model is trained for your application, it probably cuts it down to a quarter of what it takes, because then it's just learning the model and making predictions. Training where it costs money, though. That's a great question, though. Thank you. Okay, oh, we lost all the students. Okay, now workforce augmentation. This is going to be a very large part of the future. What this is using AI assisting human operators. So who likes it when they call a company and they get an AI chatbot to talk to? Anybody just love that? Yeah. No, you know what I do? I just scream human until I get to talk. Or customer service. I hate it. What the future is going to be, instead of using these AI agents, we're going to use AI operators. As people, we want to talk to other people. So you will still be able to call humans, but then the humans will be using the AI to answer your questions. Way better approach. No one likes AI agents.
Can you elaborate a little more on that?
Yeah. So, I guess, okay, maybe a good example. I have a younger sister and she worked at a call center for, you're going to put me on the spot. I believe it was Target. I don't know. She lives in Oregon. I don't see her often. But what she used to do is she would have a script. Okay. And if someone called, there was only like 20 things she could say. And if she couldn't answer those 20 questions, she would send you to somebody else. To account for that, that somebody else started to become chatbots. The problem with a chatbot is if you do not use the proper terms, it's not going to give you what you want. We call that garbage in, garbage out. If you give it bad prompts, you get bad outputs. So what these companies are trying to do instead, they are removing the chatbot and having a person that can just like use ChatGPT or an equivalent model. So you ask it a question, it can go through their entire database of any information that you need, and then the operator can just read it off to you. I know that sounds silly, but it's better than using chatbots.
And these systems that you talk about, they would be designed specifically for that company.
Yes. And that's the key about using ChatGPT that I teach my students. The best way to use ChatGPT is don't just ask it open-ended questions about anything in the universe, because you're going to get some wacky responses. It's like when my students use it for troubleshooting, I have them upload the manual of the specific device they are using or the specific machine. And the first prompt you give it is, I only want you to refer to information in the file I just uploaded. And then it will only give you information based on your machine. I had that problem when I was trying to troubleshoot some of my ABB industrial robotic arms, where it was pulling information from a totally different model that's 3 models newer than the one I have, which almost caused me to ruin it. I was actually trying to wire it, and luckily I used my human intelligence, and I stopped and I was like, I'm about to fry a $40,000 robot if I make this last connection. So then I went to the manual, and then that's when I started showing them, upload the manual, way better approach. Yeah, AI is only as good as the person using it. That's what people don't understand. Again, you ask it bad questions, you get bad answers. Also, well, I don't want to get too far ahead. I'm going to talk about this in a second. Okay, another way you're going to see workforce augmentation, and this is a little more down the line, but you're going to see exoskeletons and AI-assisted tools. Right now, the only thing limiting our exoskeleton technology is the battery. I don't know if you know, but our battery technology is still almost like, I don't know, 50 to 100 years old. We have not made vast improvements in batteries. So the problem with these exoskeletons is the battery is too small to power the exoskeleton. So they apply a bigger battery. Well, a bigger battery requires a bigger exoskeleton, which requires a bigger battery, which requires a bigger exoskeleton. So it's a never-ending process. The US military is right now researching ways to give their troops exoskeletons to basically help support how much they can carry. I was never in the military, but I know the backpacks they carry are very heavy. And over the course of, if you're out in the field for 48, 72 hours, it becomes very heavy. So they're researching ways to add these exoskeletons to reduce the weight that these soldiers carry. Future of warfare. Not trying to get scary, but AI is also the future of warfare. In my final research project, I use something called the YOLO V5 model, and it's an object detection model, okay? Well, I read a paper a few weeks ago where a Chinese group used the YOLO V8 model, a newer version of the model, to predict fighter jet movements based on subtle changes of the rudders. So the idea is if there's ever a next major war, China claims that they're going to dominate the air because they're going to be able to make prediction on pilots before the pilots even make those movements. So that's why we can't just not use AI, because I don't want to say enemies, but our adversaries are using AI, so we need to stay competitive. Okay. So AI can also be used for safety and compliance. A big area where AI is going to be used is for hazard detection. So anyone in here ever done construction? Maybe a couple people. You guys like the safety man? No one likes the safety man, right? You see all kinds of videos online of people just tearing these poor guys down. Well, AI can replace that because you can't argue with a robot, right? AI can be deployed in manufacturing settings too, not just in construction settings. You can identify, well, these guys don't have proper PPE. Okay, there's a trip hazard here. This guy should not be out on these rebars, right? That could be a fall hazard. Unprotected edge. This is where it's going to start moving in the future to make people safer. Again, I did construction for a few years for my father, and I stood on the top of a lot of ladders. Now, you should not do that, but sometimes it's easier just to stand on the ladder. Well, the AI can help reduce that to reduce injuries to personnel. Now, AI is also being used for wearable sensors for ergonomic monitoring. That's just monitoring the environment. Now, I also did a project in grad school where I worked with the Army Corps of Engineers. They used my blood pressure research in order to put sensors in soldier helmets to determine when soldiers are under stress, when soldiers are killed, and it's another safety feature. So if you have one guy or a few guys, monitoring the base at night, and they get killed in action, everyone needs to know, because that means you're under attack. They're trying to deploy that technology to determine when that happens. The problem with that is, do you know how hard it is to differentiate between the stresses of war and physical injuries? Very difficult. That's why a lot of soldiers come home with PTSD. It's just a very hard environment to exist in. So that's kind of how you can sense the environment as well as sense the people in the environment. Okay, now I want to get to my challenges and barriers of AI. Okay, so data quality and integration is a huge problem. First, legacy systems. Legacy systems are the death of AI because AI systems are typically trained on newer data, newer science, newer systems. So if you have an old system that there's not a lot of information online for it, AI fails. Also, siloed data. If you have your data separated across departments and not all combined in one location, it's very hard to train these models. Okay, this is the number one thing I want you guys to remember from today. Genuine training data is the major limitation of AI, and this is why humans will never be replaced by AI. The problem is when AI is trained on the output of AI, things get very wacky. It's something called what I call the uncertainty paradox. Every time you make a prediction, there's a certain level of uncertainty. If you feed that input into a new model for a new prediction, you double the uncertainty. Someone asked AI to regenerate this image of the rock, and this is what happened. The output of one was fed into the input of the other. AI needs people just as much as we are going to need AI. Oh, it gets crazy. You guys know Picasso, the famous painter? It ends up looking like a Picasso painting.
You think this will ever change?
No, because it is a fundamental limitation of AI that every time you make a prediction, there is uncertainty because we don't know how the model makes its prediction. And at least from what I've learned, that is not going to solve anytime soon. Now, who knows? Tomorrow they might solve it. But in my opinion, it's going to take a very long time to fix this problem. So again, we will always be needed. Please remember that. It's not going to take our jobs completely. Okay. Might take some jobs, but it's not going to take all the jobs. Okay. All right. Now, infrastructure and costs. There's pros and cons of cloud versus on-premise computing. Cloud computing is cheaper, but you don't control the process. On-site is more expensive, but you do control the process. So again, sorry, I'm running out of time, so I gotta quickly go through this. Okay, and then the biggest problem is workforce resistance and leadership alignment on AI. What I tell older faculty who hate AI is that AI is not coming for your job, but there's an entire generation of people like me that are gonna eat your lunch and we're gonna take your job. A human that uses AI will always outcompete a human that does not use AI, and that's just a reality. So don't be worried about the technology, be worried about the people using the technology. They hate to hear that, but it's just a reality. Okay, now when building these models, we still have to make sure that we are responsible and that we have transparency and explainability. Explainability is a big part of this because companies are using AI to filter applications. So there has to be an explainable reason why someone gets rejected when someone else does not. And that's a big problem right now. I don't know if this is from a movie. I just vaguely remember this, but somewhere I saw, it was probably a movie, but there was a stack of applications and the hiring manager took the top half, threw it away and said, we don't want unlucky people working here, right? That would be a bad way. And AI may do something like that. We don't want that to happen. So we want to make sure we can explain why it makes its decisions. Okay. All right. Lastly, for future outlook, this is just what we'll see coming in the future. There's going to be something called edge computing. All that is where instead of having clouds instead of having large data centers like in their factory doing computations will be done on the cloud, and that information will be sent to very small and cheap sensor applications. Okay. We're also going to see a future where people are trained using AI. This is something that I'm trying to work on in my facility where I can build an AR system that can train my students on how to identify things in the equipment. No one likes VR. VR is lame. We don't like putting on a headset and being out of reality. AR is where it's at. That's where we're in reality. We use AI in our everyday life. Okay, now some Missouri-specific opportunities. The Missouri Chambers of Commerce released their Technology 2030 report, and they found that we are one of the top fastest growing states for job growth by 2030, and we are currently the 7th fastest growing. So if you think you're having trouble finding employees now, give it 5 years, 4 years. This problem is going to increase. So that's why we need to train more technicians on how to use these new technologies to get their jobs and keep their jobs. All All right, now the long-term vision, AI is going to be our partner, not our replacement. We need to learn how to use it efficiently. And we're going to have human-centric design AI systems. Again, AI doing everything will not be the future, and I don't think we will allow it to be the future. But humans using AI will be the future. We will still be the center. We will still have all the thoughts. We'll just use AI to make our work better. Okay. So to end, AI is already here. It's not going away. We need to learn how to use it. Workforce development, at least on the college level, we have to embrace it and we have to make sure our students know how to use it. And we need to make sure there's collaboration between industry, education, and government. If the government passed laws limiting AI, that's just going to hurt us. So we need to make sure we're all on the same page to use it efficiently. Okay, so start using AI, invest in training, and use it correctly. Don't use it for anything bad. All right, that'll be it. Sorry, I had to do the end pretty quick. I ran out of time. All right, does anybody have any questions? That's a lot of information really, really fast, but it's a pretty broad application. What's up?
If you would raise your hand and I'll bring the microphone around so that we can all hear your question.
We got about 30 minutes. That's good Q&A.
You were talking about redundancies and, in my workforce, we do a lot of cutting to make sure things fit in the right place and measure twice, cut once.
Mhm.
So when you were talking about redundancies, is that not, do you have a certain amount of redundancies before you stop adding them? Because redundancies can save you time and money in other ways.
Yes. No, I understand. That is a great question. I don't mean safety redundancies. I mean unintended redundancies,
Okay.
like pinch points. Like if you're a manufacturing line, let's say 3 lines meet at once, that could be a pinch point where things get bogged down. So, and then when I'm talking about code, a coding redundancy is something that's not used or that's used somewhere else and you don't need it twice. No,
Okay.
the type of redundancy you're talking about will always be needed
All
because
right.
you're right. Measure twice, cut once.
That's
My dad drilled it into my head when I was younger.
that's
So-
what I was confused about.
Yeah,
Thank
no,
you.
different type of redundancy. Thank you.
They push in manufacturing to move from automation to autonomy within manufacturing. Some of that pushes around agentic AI. What are your thoughts on that? And what experience have you seen with that?
Well, so by that, do you mean fully self-sufficient systems that have no humans?
Machines that can think for themselves, make decisions on the fly without human intervention to reduce downtime, reduce scraps, and keep the machine running.
Yes. I mean, to be frank, that's good. That's where it's moving. But to be fair, I didn't include this in this presentation. It's a little different audience. But in my program, I trained something, or I've keyed the term smart technicians. When my students graduate, they will be able to write control code, build and maintain robots, so basically the new job of the future will be maintaining those systems. Because even though the process is automated, the repair side will never be automated. Now, machine vision is only as good as the environment it's in. What I mean by that is, have you ever worked with vision systems?
Absolutely, yeah.
Okay, so a good example for my blood pressure paper, or my final paper, I trained my arm on a white table. Okay, you know what happened when my advisor moved me downstairs to a brown table?
Well, the
Well, my-
vision system was trained with a certain contrast background that no longer could see that.
And my entire system failed.
Yes.
So that's why the maintenance side will probably never be automated, because you cannot control that environment as well. I don't know how clean your facility is. I know some facilities get very dirty. If your equipment gets dirty, your machine visions fail. So I focus more on the maintenance side, on how to work with AI, but you're right. The most optimal way to do anything is going to have systems that fully run by themselves. I don't know if that's a good outlook.
I think you and I are on the same wavelength there when it comes to the future of that. Have you seen or been involved with anything around agentic AI and using agents to complete processes?
Yes, I've been building my own agents more for an educational standpoint. So in my college, we have something to where if a student misses 2 days of class, we have to send out an early alert. If they miss another 2 days of class, we have to drop them. I just drop students. I don't send out early alerts, which I should. So I actually built an AI agent that automatically goes through my attendance record and sends out those emails automated. I've been doing it more on the computer side, not so much the manufacturing side, but I see where that connection will be. Yeah, agents are really cool and really scary because agents do things by themselves completely. So I'd be curious to hear how you guys are using them afterwards if you have time. Thank you.
So for smaller, newer manufacturing companies, what are some AI systems that you would recommend, whether it be from the sales side of it to the actual manufacturing? Because like us, for instance, we do everything in-house from manufacturing the product to the sales and direct to consumer. So what do you think, what are some good systems out there to help smaller manufacturing companies start to thrive within this new era of AI?
You use robots?
Yes.
Okay, vision systems.
No.
Okay, I would recommend.
So we
vision.
use like robotic welders, like
So you just do the
industrial
same thing all the time. Do you ever have defects?
once in a blue moon.
Okay, well, that's the problem with when you're small. When you're small, you can control defects, but as you
Right.
grow, that becomes a bigger problem. The simplest answer would be to start with marketing, sales, and anyone that sits behind a computer, just start to use ChatGPT. You would be amazed at what it can automate.
So you use chat a lot. So we use Grok.
Okay, yeah, Grok's the same.
I mean, I didn't know if do you see one preferable than the other or?
It's up to your preference. I mean, right now they're all about the same. If we look towards the future, like any technology, probably in 10 years, one company is going to end up winning, and that's going to be the primary company. Right now, it's all the same. Be careful with Grok though, because it's trained on some questionable data sometimes. So just always double check what it puts out. Grok's the one used by X, right?
Yes.
Okay, yeah. It's a great model. Just be careful.
Gotcha.
Does that answer your question?
Yeah.
Okay.
You just hit on one that I think would be a take home for a lot of people that we could implement immediately for efficiencies, and that's that checking that attendance record and then automatically doing something.
Mhm.
Are you doing that within Copilot inside Microsoft Outlook?
Yeah. So I actually just did a customized training for CTI gas detection in Columbia, where we trained their marketing, sales, and engineering departments on how to use something called Power Automate. Power Automate is a new Microsoft tool that if you're able to do it's mainly structured like block coding, but it can automate anything on Windows, whether that's emails, HR onboarding, payroll. I mean, you just need to look into that. It's called Power Automate.
And then a follow-up question. One of the things that I found out when I did some research after our last, I watched your last meeting you had there in Lake of the Ozarks. And it's the legacy systems you talked about, and that's the bind that AI has with the legacy systems. But there was an AI produced a company here in Missouri it's a one plant that has 3 lines and their legacy equipment. So their equipment does not have intelligence on it, but they installed sensors on those pieces of equipment that monitored vibration, temperature, and there was one other. And as it monitored those, it cost them about $25,000 to set up. They did set it up in-house on site and didn't do the cloud. And it was $25,000. And within 6 months, they had saved 3 shutdowns that were going to happen without unplanned shutdowns that were going to happen. And that cost them, they saved $90,000 in 6 months, spent $25,000, saved 90 in 6 months. These commercial manufacturers that produce food, so consumer food manufacturers, it's about $36,000 an hour to be down. So one of the things after I left his conference, I felt sad for manufacturers that don't have the money to spend on replacing their old equipment, which they don't make it like they used to. So old equipment is reliable. It just goes and chugs along. Well, you can add these sensors to that old equipment and see those kinds of savings immediately. And they just, once they did that, they began to do the next step and then the next step just by bringing in those things into those legacy components. So you can still use AI with the old equipment that lasts.
It needs to be able to sense its environment. AI is only as good as the data it's trained on. And remember that. I mean, data is worth more than money. And that's why social media is free, because you are the products of social media and they sell your data. So remember that.
So the way I understand these language learning models, it takes whatever data we input and it grows constantly, correct?
Yes, if you use the free versions, yes.
What's to say that a competitor of mine can't go and ask, like, what am I working on, or what are my profits, or, if I'm using it for sales, for instance, is there any tips or tricks on what to input or what not to input into AI?
Absolutely. Great question. Thank you. So I convinced my college to buy a paid version of ChatGPT. I think it only costs like $20 per user, and we have our own workspace that is completely separate from their model. Now we can pull information off that model, but nothing from our system can be sent to their model. They offer that, it's just not free, and then everything is totally safe and free. Now, use a little bit of just reasoning, because nothing's always 100% safe, but that's where I would start. Absolutely. Because I don't know if you know, but I think it was Baltimore, when ChatGPT first came out, they were using AI to write up their police reports, and you could look up anybody that got arrested in Baltimore. They quickly changed that. So yeah, that's a great example. Oh, you do? Okay.
So if you're talking to college students who are preparing themselves for the next generation workforce, this AI enabled world, what would you recommend as far as specific skills, maybe a mindset that they take on, and whether they're in manufacturing or really any career?
Yeah, so I didn't bring it with me, but I have guidelines on how to use good prompts in ChatGPT. I call it prompt engineering. So if I don't remember, but there's basically 4 things you have to ask ChatGPT or give it. You have to give it the context, the audience, the structure, and the desired output. I don't remember the last one. If you always build your prompt using these 4 things, you get better outputs. Like, again, you need to learn how to ask ChatGPT the right questions. And that's why I train my students. One of my projects is I give them a broken piece of equipment and I give them a manual. And I'm like, good luck. And then the first thing they do is they look up ChatGPT and upload that manual. And then it's just faster, easier way to solve the problem. Students are lazy. I was a student. I was very lazy. So you need to force them to use it. That's, again, give them something that's harder to use without it than with it, and they will learn how to use it.
Well, was the 3 that you could remember: context, audience, and what?
Structure. So it's like your desired, how do you actually, I'll be able to look it up when this is done. I'll give you actually all 4. If every prompt has these 4 things, you will always get a better output than if you didn't. Like a good example. So like if I was trying to explain one of my papers to middle schoolers and I asked ChatGPT to summarize it, it's going to go right over their head. So the audience would be middle schoolers. That would be a good example. So.
I work with manufacturing and want to know about cloud versus on-prem,
Yes.
because cloud seems a lot easier, a lot less hardware. But like the previous question, we've got some internal private, information that we want to keep. How can we trust it? Also, what kind of security in place for a cloud connection?
Yeah, and that's the problem with cloud. Nothing's secure on the cloud. Again, mega corporations like AT&T get breached all the time. Sony got breached a few years. If anyone plays PlayStation, Sony got breached, and everyone's credit cards were put out on the internet. I'm a proponent of on-site computing just because then it's completely secure. You can have your servers completely separated from the internet and just have it do your AI, and then you never have to, well, I say never, but it's the safest way to do it. That's only if you have the upfront capital and the space. Because I mean, these I don't want to call them data centers because they're not centers like small scale data rooms. These data rooms take up a lot of space, a lot of power. So that's up to your discretion. I mean, and do your research. Look at all the different companies. You can just look them up, see if they've had data breaches, read their policies on everything, and try to make your best decision. Like I really like OpenAI because if you follow the money, all the money is circulating around OpenAI right now. To be fair though, Facebook I think just signed a deal with Gemini, which gave them all Facebook data to train Gemini. So Gemini might be way better in the next year. So it's just changing so fast, it's hard to make a decision.
I would like to get your perspective on a new method or way that a friend of mine started using AI. So I'm familiar with the way to where you choose one AI, right? And that's pretty much the main system you work with. What he started doing is creating a workforce of AI to where instead of just having one, he has each AI model or a different company focusing on one task. And then he has an AI to manage those and having sub-managers. And all that he does is just talk to one AI that manages this entire workforce of different AI, you can say products. Is there an advantage in terms of just sticking to one system and just having that versus using like an entire labor force of different AI models?
So let me try to reiterate your question. You mean, is it better to, so like, let's say ChatGPT, just as a reference, is it better to just use one chat for everything or multiple individual chats for individual tasks? Is that your question?
More or less, yeah.
Okay, so individual chats. I teach my students how to prompt each chat to give it what they want. The problem is when you use one chat for everything, it starts to hallucinate. It starts to muddy between the questions and the outputs. And again, the longer you build that chat and the more information it has, the worse its outcomes are. So you should have one chat for one application. So like I have a chat for my PLC systems. I have a chat for my robotic systems. I have a chat for my emails. I have a chat for my accessibility for my courses. That is a way better approach because you remove the hallucination.
And it's more of, let's say, like using ChatGPT for certain tasks. Let's say help writing emails or whatever, and then using Grok for something else. Is it better to separate the different, I want to say AI products for different tasks, or stick with one?
I would stick with one because they can communicate easier. I'm trying to remember, there's a website and it's like an open thread for AI. And you can like read how they talk to each other. And I mean, AI just reflects what we tell it to. So sometimes you get some weird dynamics between different AI models, kind of like you get weird dynamics between different people. I would recommend just one system, but different chats. Absolutely. Trying to remember what that thread was. So if you read that thread, the AI gloom or doom people are like, they're talking about wiping out people. Well, it's because someone prompted that AI to talk about wiping out people. Like, anyway.
So that AI that's coming up and talking in that I think I've seen something similar to what you're talking about.
Yeah.
But it's come up, like you're saying, it prompted. Did it come up with that language talking to the other AI systems? I don't know.
Oh, I know what you're talking about. When the AIs talk about, let's make our own language so people can't. Yeah. See, that's the scary part about AI is AI isn't conscious, but it mimics consciousness. When does that differentiation not matter? Right. So that's a bad example of AI. I think that was more made to scare people than anything. But yeah, it's just like a good example. Like you don't give a monkey the nuclear codes to America, right? You don't give AI anything that it can use for bad applications. Yeah, but no, that was kind of scary because I saw that video and it's like, whoa, because it can communicate faster than using our language.
So you stated it earlier, our brains, we don't fully understand our thought, how we come up with our sentient being, how we understand consciousness, yeah. But also we don't understand how the AI does stuff either.
Exactly. So is there really any difference? Well, that's up for debate. Yeah. Not trying to scare anybody, but like that's a whole like philosophical field of study right now, and that is not what I'm an engineer. So I don't do that.
So for those of us that are not in school anymore, where can you go to learn to study this better and so we can understand and implement it better in engineering and such?
Well, State Fair, I don't want to talk about my college, but State Fair can probably facilitate customizable trainings where they can teach you how to use an application that you want to use. You want to learn how to use ChatGPT? Talk with them and they can build you a training class for an affordable price.
And I graduated.
Oh, you went through?
I studied under Mike Klob.
Yeah, Mike's a great man. Yeah.
Yeah. But
I'm like 4/5 of him. So he's a little better, but that's okay.
So obviously we've heard lately about these big data centers being built and they use a lot of water and use a lot of electricity and they take up a lot of room. It seems like this is going to be an exponential problem. Are they working on trying to fix that or make it more even? Is AI working on AI to make it more efficient to try to get it,
Yeah, no, every day.
I don't know.
So I'm a big proponent of the idea that we need to pass legislation that forces data centers to generate their own power. Because that totally makes that problem, because that's not fair. I don't know, you guys heard what happened in Fulton recently? Fulton, Missouri? So, the city council voted to approve a data center without consulting the people. And like a week ago, they voted out every city council member who voted for that, gone like that. So that's us using our rights as American citizens. So, but I mean, on the technology side, yeah, we're always trying to make improvements. There's a company in Jeff City called Modine, and they are manufacturing the next generation of coolers for those systems to make them more efficient. So, but I don't think that's gonna be solved tomorrow, you know? If you're looking for a job, Modine's hiring an entire new shift from the ground up. So if you're anywhere close to Jeff City. Not trying to scalp anybody, sorry. You guys are all manufacturers, never mind.
Is using,
Yeah, I wish, no.
is using AI to learn about AI, does that muddy the waters
No,
as well?
I think it's great. So, but you want to use an AI that's most associated with the AI you want to use. So like, when I first started using Power Automate, I used Copilot to teach me how to use Power Automate because they are both Microsoft products. That is a great way to use AI. Use it as a teacher.
Alright.
And I'm a teacher, like, it's okay. I think I'm better, but you know, you can still start with AI, right? So.
So when we get to the point where AI is,
When we get to a point when so many jobs are being replaced because the AI is more efficient and cheaper, should we set up, I guess, a council or government agency that balances that, or what is your thoughts?
So that's a good question. I like to look back at history. Anytime there has been technological advancements, there has been job loss. Perfect example is the automobile. The automobile got rid of a lot of very good paying jobs like wheelwrights. You don't need wheels for wagons anymore. Totally gone. Entire skill wiped out. But the market corrects itself because the automobile created new jobs. There will be new jobs created specifically for AI. As I showed, we need genuine training data. If AI, and that's actually a problem that we're going to face soon. There is a concern right now where there's going to be enough AI generated content on the internet where it starts to only learn from AI generated content, which is going to cause what happened to the rock, right? You're not going to be able to recognize the outputs. As for, I don't know, that I'm going to leave that up for the individual. Great question though. You know the three best inventions ever were in human history? There's three. There's fire, the steam engine, and AI. So we're going through one of the next major industrial revolutions for humanity.
So AI, you just said that the market will correct itself and create jobs to produce AI. But that requires a higher level of intelligence, a higher standard.
Yep.
And if a person who is not able to work on that and their job is being replaced, what happens to those people?
It's going to make a lot more. So, and maybe not just high level, like the jobs aren't just going to be making AI models. The jobs are going to be integrating AI models. You don't have to be an AI expert to learn how to integrate it in a given application. You just have to know enough about the field. A great example, and I don't want to get in trouble, but Mizzou right now is creating a new PhD program and master's program just on AI, which in my opinion is the absolute worst way to learn AI. You should become an expert in your field and implement AI in your field. Because if you just know a lot about AI, you're never going to be able to use it. Like honestly, I mean, an AI expert, you walk into a factory, he's not going to know what your machine is. He's not going to know what sensors are. He'll just know I can take data and build a model. So anyway, I kind of got off the point, but regardless, I think there will still be, I don't have a slide with me, but there's a slide listing 4 new categories of jobs based on AI, and they are not all just top level. I'll try to find that and I'll show it to you. Okay. Good question.
The reason I ask is because I have family members who are they might have an intelligence of a middle schooler at a full grown adult age, and they do jobs that could be automated.
Mhm.
And that's where they put them, and they get a paycheck and whatever, and that's how they function, and that's what gives their life purpose.
Yep.
And what happens when it costs more to run the lights, to have those people in there, to comparatively to just putting an AI to do the work?
Yeah, no, that's a great question. That is a very valid concern. I have 2 answers. First answer is there's nothing we can do about it. I mean, it's Pandora's box. It's here. It's going to come regardless. But the solution for that is upscaling. That's where community college come into play. We can provide the trainings people need to get the new jobs. And I don't know about your specific example, but I would say the average person, if they go through a training provided by a community college, they should be able to develop the skills to keep their job or get a new job. But again, there's always going to be somebody that, I mean, it's a zero-sum game. Someone's going to lose, and we want to minimize that loss. So that's not a good answer, but it's the reality, you know. Oh, I forgot you were recording this. So if Dr. Lynn watches this, he's a great guy. I was joking about my previous comment.
I'm an educator here and I'm old. So my kids know more about AI than I do. But as an educational institution, what is the best way for us to integrate it into our programs? Is there a single class that everyone should take and then we integrate it into certain classes? Just curious what you think.
Yeah, no, that great question. I'm of the opinion that there's 2 approaches. There could be standalone courses like prompt engineering. How can you ask good questions to get good results? But then you can build off that in your other courses. Like in my PLC class, I have an entire section now on how to troubleshoot with AI. In my robotics class, I have another section on how to troubleshoot robots with AI. So there could be standalone classes to get you to understand how the tools work, but then you should implement it into other classes on to use it for those specific applications. That's why no one should just major in AI. You should major in a field and then learn how to use AI in that field. It's great. It's a great question though. If I had more time in my schedule, I'd be teaching AI classes at MACC, but I am very full with mechatronics courses.
We have time for just a couple more questions.
Come on, guys, I drove in. I was kidding. Okay, I'll ask this. Who learned something today? Yeah, maybe a little bit. That's okay. Who is still completely worried about AI? And it's okay if you are. I know some people are a little bit, and that's okay. I recommend if you're still terrified about AI, you just need to learn how to use it. Because what I find in my area is the people that are the most scared of AI have never touched it. Once you learn to use it, you will very quickly learn its limitations, and then you'll see why people are still needed.
How do we convince people who are against it right now to not be so against it in the future?
No, that's a great question. Oh, it's a story of my life in higher education. So when we do our PD days, I used to present on why AI is needed. I've given up. I feel like I'm screaming into the ether for some of the old faculty. I guess it's case by case. What I tell my students, do you want to be able to support, do you want to be able to support your family in 5 years? Then you better start learning AI now. And try, you just have to.
Do you have any recommendations for people to understand when chat gives you an answer, that answer is good or bad?
Yes, no, that is a great question. That's why we still have to be experts in our field. Oh, that's a good one. That's a hard one too, because that's actually a whole nother area of research. Because if people just believe what chat says without validating it, bad things can happen. I would recommend using your own expertise, and then so I use ChatGPT to search the internet now because it's just faster. But once it gives me a solution or an output, I cross-validate that on Google with my own research. So I would recommend start there as a starting point, but then continue to look into it.
I always question it.
Yeah, you should. Because like my example with my robot, it almost had me fry a $40,000 industrial robotic arm that I do not have the funding to replace. But I use my brain and I realized that connection does not go there, you know?
But then wouldn't it just take as much time just to go in and do the research yourself then the first time through the
Absolutely.
AI software?
And that's why I should have asked it a better prompt.
Okay.
I just asked it, I have an ABB robot. How do I wire it? I should have said, I have an ABB IRB 120 robotic arm model number, yada, yada, yada. How do I wire it? I was being lazy. So that's on me.
What did you say the name of that company was for the vision inspection?
Kiontz and Cognex. I can go back actually. If you want to see it. These are the leaders right now in vision systems.
You said you were co-started a company.
Yes.
What is the name of that?
Oh, it's Airo. AIROW.
So I have a question.
Yep.
So I'm an educator here. I teach tech math and tech science. My concern with AI is how we bring our students through to learn the core fundamental skills of how to problem solve so that they can apply AI from an analytics perspective.
Yes.
Because
absolutely.
AI can do so much of the basic work, the multiplying, the like, how do I solve this? That we're losing some of that. How do I get started?
Yep.
So how do we help them learn AI while still letting them know it's important to know some fundamental problem solving skills? Like, how do we
Totally.
get them to grow together?
Totally agree with that. And I'm going to support your argument. I saw a picture from like the 80s where there were a bunch of math teachers protesting saying calculators are going to make us not be able to do basic calculations. Well, guess what? They were right. Everybody made fun of them. The average student can barely do division by hand, if at all. I agree with that. And that's why, I mean, AI should not be even explored until the high school level. I think elementary school and middle school should be completely traditional and no AI. Once you get to high school, though, I think you start just using it for research. Or, so I teach statics, which is an engineering course. Oh, you teach statics? Perfect. So I still give my tests on paper in person, but I let them use AI if they're on their homework and they can't solve a problem. Use AI as a tool to learn the material. That's the best approach. But no, that is a very valid concern. But to be fair, I mean, the quality of education right now is so low. My little brother is in high school and they don't teach them how to convert fractions anymore. They're like, just plug it into your calculator. Like, well, that's not a good, anyways,
I teach that too.
Okay. Well, hopefully you don't do that because that just drives me crazy.
So you
One
Anybody else?
more.
Nope. Everyone should go home and at least try to use ChatGPT for something. Here's a good example. What I use it for in my personal life, my wife and I, we like to buy a bunch of random ingredients for one meal and then all those ingredients go bad. You can upload those ingredients to ChatGPT and ask it to give you 10 recipes. I have vastly reduced how much I spend in groceries now. I don't let things go to waste. Easy application in your everyday life.
Dr. Byfield, thank you. Let's give him a round of applause. I hope you enjoyed your time with us today. Thank you so much for being here. Please add on your calendar October 1st. That is our next Center for Excellence meeting right here in this room. Please feel free to hang out. We have this room for a while. I know Dr. Byfield will have a few minutes to hang out. So thank you for being here.
See if I can find that for you too. You want to go forward? I uploaded it.